All right, we're going to do the Chapter 2 extension, which is absolute value. And absolute value is a measure of distance. So if you look at a number line, what is 7 away from 0 is both positive 7 and negative 7. So the absolute value of x is positive 7 and negative 7. You could also write that like that. So you could write x equals 7, x equals negative 7, or just the positive or negative 7. So the absolute value of x equals negative 10. What is negative 10 away from 0? And that's nothing. Absolute value makes everything positive. It's a measure of distance. Therefore, the absolute value of 1/3 is positive and negative 1/3. When you're solving for absolute value, the first thing you need to do is isolate the absolute value. This one's already isolated. I'm just going to go ahead and write my x on the left so it's in proper form. And now that the absolute value is isolated, since it initially was, I know that x plus 3 could equal 9, and x plus 3 could also equal negative 9, because the absolute value is a measure of distance. So I need to just solve each of these. So x could equal 6, and if I subtract 3 over here, x could also equal negative 12. Let's test these numbers and make sure they work. Negative 12 plus 3 is negative 9, and the absolute value of negative 9 is 9. So that one works. Then if we test 6, 6 plus 3 is 9, and the absolute value of 9 is 9. So that one works. So those are definitely our two answers. In the fifth one here, before we do any sort of changing things to positive and negative, the absolute value needs to be alone. So we need to get rid of that negative 2 by dividing. A number next to a letter's multiplication. So to undo it, you divide. So now we have the absolute value of x is 6. Therefore, our answer is just positive and negative 6. The next one's the same thing. We're just going to isolate the x. The absolute value of x is 6. So it's positive or negative 6. All right, this time we need to first isolate the absolute value. So let's get rid of 5. So we have the absolute of x minus 1 is equal to 6. A lot of 6s. Must have been feeling 6. And then we're going to do the positive and the negative. So x minus 1 would equal negative 6, and x minus 1 could also equal positive 6. That's how you get the absolute value off. And then when we solve each of these, x can equal negative 5, and x can also equal positive 5. I'm just totally kidding with that. X can also equal 7. It's not a positive negative thing. Let's just check this to make sure. So 5 times negative 5 minus 1. Negative 5 minus 1 is negative 6. So 5 times 6, because the absolute of negative 6 is 6. That is 30. And let's check the 7. 5 times 7 minus 1 is 6. So 5 times 6 is 30. All right, things are good. We're going to isolate the absolute value by first adding 7. When you undo something, you usually undo the order of operations in reverse order. So now we have 2, absolute value of x equals 10. And we still can't do the positive negative yet until we have the absolute value completely isolated. So the absolute value of x is 5. So our answer then is positive and negative 5. This time, we're going to divide by 3 to isolate that absolute value. X plus 2 is 6, again. And then we're going to make it the positive and the negative, because the absolute value of x plus 2 could equal negative 6. And it could also equal 6, because that's what's in the absolute value. So when we solve this, we're going to subtract 2. So x could equal negative 8. And then if you just want to think real quick, negative 8 minus 2, negative 6, that works. And then if you subtract 2, x will equal 4. Let's just think again real quick. 4 plus 2 is 6. That works. So those are definitely our 2 correct answers. This time we're going to subtract 10 first. 4 times the absolute value of x plus 1 is 8. And we're going to divide by 4, because again we want that absolute value of x isolated. So x plus 1 absolute value is 2. Now we're going to make it positive and negative, because we're going to solve this problem without absolute value. So x plus 1 could equal negative 2, because it's in the absolute value. And x plus 1 could also equal positive 2. So when we solve each of those, we get x is equal to negative 3. And we get x is equal to 1. And we can plug them into the initial and see that they both work. 4 times negative 3 plus 1 plus 10, does it equal 18? So that's 4 times, this is negative 2, which is 2. 4 times 2 is 8, plus 10 is 18. So that one works, and if you plug 1 in, 4 times 1 plus 1 plus 10, that's 4 times 2 plus 10, so we are all good. In 11, we have the absolute value already isolated. If you get something ever where you're having an absolute value equaling a negative, it is no solution. So you don't have to get anything. If you do solve it and get a couple numbers, when you plug it in and check, it doesn't equal the negative when you take the absolute value. So that's how you know it's no solution. And finally, a little story problem. My walkie-talkie has a range of 3 miles. So that means something in the absolute value is going to equal 3, because that's the plus or minus 3. And I'm on Highway 96 at Okemos at 110. Write an equation to find the maximum mile marker my walkie-talkie will reach. So this 96 is totally meaningless. It's just the name of the highway. But the 110 is the thing that I'm going to be adding to the plus and minus 3. So that means inside my absolute value, whatever my answer is, which will be 3 more or 3 less than 110, I would have to subtract 110 from to get 3. So if I solve this, x minus 110 would either equal negative 3, or x minus 110 would equal positive 3. So if you add 110, I would get x equals 107. And if you add 110 here, I would get x equals 113. So my mile marker range is between 107 and 113, which makes sense, within 3 of 110. And so you just set up the story problem using this absolute value equation. You probably don't even need an equation to do that. That one's a little bit easy, but you do need to be able to set those up when our problem's harder. Have a great day.